Welcome back, everyone. My name's Ciarán McGonagle. I'm Chief Legal and Product Officer at Tokenovate. And I'm going to be spending the next 30 minutes talking about tokenization in CDM. I'll begin with a brief introduction to Tokenovate and to myself before talking about tokenization, what it is, really trying to deconstruct various different tokenization products and structures and what impact that has when thinking about modeling tokenized assets and tokenized workflows within CDM. And then I'll go through a few different use cases that we've been exploring within the industry working group. So a bit of introduction to, I think, Tokenovate first. So Tokenovate, we're a post-trade automation platform for derivatives and SFTs. So what that means in practice is that we have a platform which takes trade messages relating to both derivatives and SFTs. We take them in any format, whether it's FPML, FIX, ISO, and we run it through an automation engine which is designed to automate various different business events in relation to those trades. The engine is all completely embedded within CDM, so it takes the existing process and workflow and product structures from CDM and essentially turns them into a runtime engine that is capable of automating all of the various different events that occur across derivatives and SFT events, whether those are trade executions, contract formations, transfers, resets, and other sorts of lifecycle events like novations, amendments, etc. We also have a tokenization solution, which I'll talk about at various points through this presentation. But the way that the tokenization product interacts with the CDM engine is that as we model transfers within our engine based on the CDM transfer business event, we work to embed within the CDM structures various different tokenization and token-specific attributes that allow us to interact with the blockchain and allow us to transfer assets and settle tokenized assets and reflect the fractionalization of assets and the various different features and programmability that you can include within tokenized assets. A little bit about me. So as mentioned, I'm the Chief Legal and Product Officer at Tokenovate. So I am a lawyer. I don't have a technical background necessarily, unless you say that derivatives lawyers are technical, which I suppose we are. Previous roles, I spent 6 or 7 years at ISDA. Spent a few years at Deutsche Bank, Morgan Stanley, began my career at A&O. So that's about 15 to 20 years in total, working as a lawyer within derivatives and capital markets. So I think at ISDA in particular, I worked and developed on a lot of the data structures that currently underpin the CDM legal agreement model, such as the ISDA clause taxonomy and ISDA clause library. I led ISDA's work on digital assets and tokenization and led development of the digital asset derivatives definitions, which was the first definitional booklet covering digital assets and crypto assets. And over the past 6 or 7 years, I co-authored a number of different papers on smart contracts. So looking at various different asset classes from interest rates to equities to FX and more. And looking at the legal and documentation structures primarily and trying to establish or understand where we could implement new technologies like DLT, like digital assets and tokenization within those structures in order to promote the sort of more efficient functioning of those products. I'm also chair of the CDM tokenization working group, and I see quite a few people who are members of the working group here today, which is really nice to see. And I'll end with a little bit of an explanation on the work of that working group towards the end of the presentation. So in terms of background and context, and apologies in advance for the history lesson, but I always find I find it personally useful when I try and think about what tokenization and tokenized securities in particular are, what the benefits are and what the features are as compared with kind of traditional securities, and why the tokenization market is developing in the way that it is being developed. And I probably encourage a little bit of caution. So I think this is primarily with a kind of a legal lens. So as mentioned, given my background, I look at things primarily from the perspective of the property rights and the legal rights which are wrapped up within tokenized assets. But I think that is obviously an important part of this. And if you work in tokenization technologies for any period of time, I think you quickly realize that this is a multi-dimensional product, in that you have kind of legal characteristics which you need to think through. You obviously have the technological characteristics and the operational characteristics. So I'm going to start with some of the kind of the broader legal characteristics, talking about what these things are at a very fundamental level, before then going into talking about how CDM can help to provide some of the framework for the operational characteristics, essentially how we embed tokenization within either traditional financial market infrastructure or develop new financial market infrastructures that are interoperable with the existing. So we go back, way back in time, 300 odd years ago, that sort of securities started with bearer securities. And I think most people probably know what they are. So they are the kind of classic paper-based securities. If you've ever watched cowboy movies, you'll see that whenever they rob a bank and they run out with big bundles of paper, that's typically what they're stealing. And they were the first way that I think they were originally designed to kind of raise money for wars, but they were the original way in which societies tried to embed contractual rights relating to debts in a legal manner. So by creating a paper-based document, I could issue debt and pass it to you. And the purpose of giving you that piece of paper was that once you gave me the loan, you were able to demonstrate that I had a debt to you, and you could use that piece of paper to evidence the fact that I had the debt to you, and you could cash in that piece of paper at the maturity point, and that would require me to then repay the principal amount. You also had coupon payments, and the coupon payments are demonstrated by coupons that you would tear off the paper-based security and hand them in either to the issuer or to the bank. And of course, that's where the term coupon comes from. So history lesson over, I think, just to sort of set the scene that all securities can start with the world of bearer securities. And as the market has moved on, as we moved into a world of dematerialized securities from the 1980s onwards, I think that was all really driven by some of the weaknesses and the issues that were becoming increasingly evident in the world of bearer securities. So obviously, if you have a piece of paper demonstrating that you own a debt, if that piece of paper is destroyed, if it's stolen, you'd very limited legal recourse. You could say that ownership of that property, ownership of that debt, was evidenced by possession of the physical certificate, and that word's important. I'll come back to it. With the advent of personal computers and all sorts of other techie things, we entered into the world of dematerialized securities. So again, if you've seen like a 1980s film like Wall Street or anything like that, where they're all sitting around computer terminals shouting bye-bye, sell, and working on what looked like fairly primitive Excel spreadsheets, that is essentially the world of dematerialized securities, as was the case in the 80s, and actually probably quite similar to how it looks today still. And the difference between bearer securities and dematerialized securities was that the securities themselves no longer existed in possessible form. They weren't paper-based. You couldn't physically possess them. Instead, those securities, ownership of those securities was demonstrated by an entry, a book entry in a ledger maintained by a central securities depository or perhaps a custodian or nominee on behalf of the CSD. And in that way, the kind of what happened as a result of that was this system of intermediated securities or indirect securities ownership was created, whereby we had sort of fairly complex webs of CSDs and custodians and banks all kind of holding in a chain rights and beneficial interests to the ultimate legal title to the security, which was held in the CSD. And so what we gained in efficiency, perhaps, by being able to transfer securities by way of entries, book entries within a centralized ledger within a CSD, we probably lost out in terms of increased complexity within the system. So the world of intermediated securities is highly complex. In fact, if I buy a bond today through my Vanguard account, I'm actually not registered as the legal owner of that. It will be the CSD who holds it, probably via at least one custodian or nominee account. And so ownership in the world of dematerialized securities isn't demonstrated by possession. It's not possible to possess a dematerialized or electronic entry in a book, in a ledger. It's evidenced via control. And again, that concept is important. Those dual concepts of possession and control. Because as we get onto the world of digital securities, and if we start with cryptocurrencies, those two concepts begin to kind of fall away. You can't possess Bitcoin, for example, and there is some doubt as to what control of a cryptocurrency or what Bitcoin actually means. And so within legal circles, this sort of generated an awful lot of excitement over the past 10 or so years, where people were really trying to establish, are cryptocurrencies, are digital assets, capable of creating property rights? Is it possible, as somebody who owns a cryptocurrency, to enforce a right, whatever that might be, against somebody else? I think those questions have been largely resolved by now. The Law Commission in the UK have published a paper which proposes that control of the private key itself is sufficient to demonstrate some form of legal control. And there's a bill going through Parliament at the moment which aims to give some legislative force to that analysis. But without wanting to kind of bore you a little bit more with the underlying property law analysis, I think the point I'm trying to convey here is that as we move increasingly from a world of old bearer securities to dematerialized securities, each of them representing a fairly fundamental paradigm shift in how securities issuance and securities holdings and trading were characterized from a legal and operational perspective, we're arguably entering a new paradigm now with tokenized securities and digital securities, where a lot of these existing concepts of possession, control, who you have legal recourse to, all of these things are really starting to evolve in different ways. And so that's the seed I want to plant as we go through the rest of the presentation. So what is tokenization? There's lots of different definitions, lots of different taxonomies for different types of tokenization structures. There are some that are categorized by reference to their sort of functional attributes. So you hear things like stable coins, utility tokens, security tokens, things like that. Some of them are characterized by reference to their legal characteristics and attributes, which is kind of, in some respects, the approach that I've just taken. But I think, put simply, when we think about tokenization, it's the technological and, importantly, the legal process of representing an asset as a digital token on a DLT system. But what does that mean, representing an asset? What that really means is, again, if we go back to this sort of idea that debt and securities and things like that are assets, and those assets themselves are really bundles of legal rights and obligations. So in a contractual security, the asset is essentially a promise that I will repay a debt as of a particular date, and an equity is giving you the legal right to participate in the governance of the company in which you hold equity to. This concept of legal rights and tokenization, tokens being bundles of legal rights, becomes, I think, really, really important. And so when we kind of think about it in that way, and we think about different types of digital assets, everything from Bitcoin to CBDCs to stable coins to digital securities, and you start to think about, well, how are legal rights embedded in those things? You start to kind of very quickly realize that tokenization, it's not a monolithic concept. There's not a single uniform way of tokenizing an asset. It varies across different technological implementations. So conceivably based upon whether the technology is a distributed ledger or otherwise, permissionless versus permission versus private, DLT. There's lots of different technological implementation. And there's lots of different legal implementation, which I'll come on to shortly. And so when you put all of these things together, as the slide says, small differences in some of those features can really impact the legal characterization of the asset. And I would argue then, as a consequence of that, could impact the operational implementation of it within the financial system, which is why I think CDM as an operational model is really very powerful when applied to tokenization, as I'll come on to. So I mentioned different types of taxonomy, kind of legally focused, functionally focused, technology focused. I think one of the better taxonomies or one of the better classification schemas is the schema proposed by the CFTC's GMAC committee this time last year. And so if you haven't seen that document and you're interested in tokenization, I think it's well worth reading. It proposes a number of different ways of looking at tokenized assets and tries to characterize them both by their function but also their potential regulatory characterization. And again, looking at it from a broadly US-based perspective, but arguably I think some of the frameworks that they've developed are sort of extendable across different legal and regulatory jurisdictions. But the one I kind of focused in on were these three. So you have crypto assets, which I kind of put out here just to, I suppose, make the point that when I think about tokenized securities or tokens, I'm not really talking about crypto assets. So crypto assets are these things which exist entirely on-chain and are completely independent of legal systems. So things like Bitcoin, things like Ethereum. And I'd be very happy to have a conversation about this after the session. But I think sort of some of the legal analysis that applies to these is, I think some of the risks, I guess, related to the legal characterization of this is sometimes underplayed, which I'd be happy to go into separately. But I want to focus for the purposes of this presentation on security tokens on one hand and tokenized securities on the other. And although they sound very similar, so similar that I often confuse the terms, they're quite different and I think inform both the way that they're implemented from a technological perspective, but also the way they should be reflected in an operational system, I would argue, via CDM. So a security token is a digital security which has been issued on-chain. So it's a digital security, the existence of which is entirely on a DLT. So in some respects, it's not massively different to a security which is today issued through a centralized ledger onto a CSD. I guess the difference is that it's issued on a decentralized ledger, which may be maintained by a central authority like a CSD, or it may be maintained by nobody. It may be maintained by the consensus of the participants. But the important thing and differentiating factor here is that this token is the sole object which represents the legal rights associated with the security. There is no entry anywhere else in any other database. There is no bearer certificate anywhere relating to that security. And that's to be distinguished from tokenized security, sometimes referred to as digital twins, which is where we create a digital representation of some off-chain asset. And that off-chain asset could conceivably be anything. It could be a bond, it could be an equity, it could be a fund containing both equities and bonds conceivably. It could be some kind of physical asset like gold or oil. And I think when you think about digital twins, you start to kind of, I suppose, the immediate question that comes to my mind is like, okay, great, I've created this digital representation, this bit of code over here which says this represents a share issued by Google, and then I have the share issued by Google which is sitting in some CSD somewhere. And so as the holder of the token, how can I be certain that there's some kind of legal link between the two? How can I be certain if I transfer that token to person A, to person B, to person C, to person D, the person D actually becomes the beneficial holder of that token? And that requires some quite careful legal structuring. But I think, again, the important point here, I think, is to note, as distinct from security tokens, in the case of a tokenized security, the digital object is arguably not a token at all. What you're really doing is introducing some of the benefits of tokenized settlement to the off-chain asset. So we're using the DLT, the blockchain, whatever it is, to make more efficient the current settlement structures that exist within intermediated finance. And that is a distinction that not many people agree with, I hesitate to add, but it's one that I find useful. So when we come into thinking about CDM and we think about those two different types of approach, as mentioned, we arguably have, within both structures, we arguably have, with security tokens, where we have the digital token, which is the authoritative representation of the asset and of the legal rights associated with that asset. I would say that in CDM, we should be thinking about how we model those as assets in the same way as the current asset model within CDM allows you to model things like bonds, equities, commodities, etc. Arguably, for things like tokenized assets, we need to think about how we distinguish them from traditional assets, and we're having, I think, a good debate on this very point at the moment in the working group. But when I think about tokenized securities, where the underlying asset, whether it's to a derivative, an SFT, or to a cash transaction, remains the off-chain asset, we're just using the token as a kind of a more efficient settlement mechanism for achieving atomic settlement or intraday settlement. I would argue, and again, we're having a good debate on the working group about this, that it's really the settlement level mechanics that we need to look at. Things like how do we represent intraday transfers, how do we represent T+0 settlement? Do we need to do anything to CDM at all? Again, I think these are good topics for debate. Just digging a little bit deeper into this. So as mentioned, and these diagrams that I'm about to show you come from a paper that was published by the UK Jurisdiction Task Force a couple of years ago, where they went into some quite considerable detail on the legal structure underpinning some of these different tokenization models, the different types of tokenization models that could exist within securities markets, particularly or primarily in the UK, and what are some of the legal questions and the legal structuring techniques that you would need to build out in order to give effect to these structures. There are 6 or 7 structures within that paper. I think it's a very good paper if you want to kind of dig a little bit deeper, but I've pulled out 2 just to demonstrate conceptually what I mean by tokenizing at the asset level and tokenizing at the settlement level, or you might refer to it as asset tokenization and settlement tokenization. So in this image here, what we're trying to demonstrate is that we have an issuer who issues some form of digital securities into a DLT platform, and is that a hexagon? The hexagon is intended to represent the platform where those securities are traded. And as you can see, there's no real centralized authority here. The asset is represented on the chain, and the participants on that chain are able to interact peer-to-peer in order to trade, to hold, to settle the securities as against the issuer. As distinct from the settlement level, where, again, what this picture is trying to illustrate is that we have an issuer, as we do in sort of traditional securities markets, who issues a security, typically held by a CSD, who holds it on account for an intermediary who is typically a member of that CSD. Let's say it's a custodian. And then that custodian may issue tokens or digital objects which represent the beneficial interest to that token on a DLT. And again, within the hexagon, you have participants in the DLT buying and selling that security. But of course, I would argue, as mentioned, that they're not actually buying and selling the token itself. What they are actually trading and exchanging is the beneficial interest in the conventional security that is recorded and immobilized at the CSD. And so, as mentioned, within these kinds of model, I would certainly argue that the CDM needs to review how it currently looks at settlement logic, things like atomic delivery. Do we need to think about smart contract execution when some of these procedural steps are automated via smart contracts? And how do we do that in a way which doesn't undermine some of the legal characterization of these assets? So it's a kind of a delicate balancing act, I might say. So that was kind of by way of background and context. So I wanted to, that seems fairly abstract and ephemeral, I appreciate. But what I wanted to do was go into, I think, 3 specific projects or 3 specific applications where I think CDM can be very helpful in driving, promoting the adoption of tokenization within financial markets. So one of those is just sort of more broadly driving standards adoption. This is the topic that we're discussing within the working group at the moment. So as mentioned, there's a lot of different ways, a lot of different schemas, data formats, taxonomies, etc., for describing tokenized assets. And I think the risk that we face as a market, as a community, is that with this proliferation of different standards, there is never going to be one kind of standard that everybody can agree to. So a standard that people can use in order to correctly identify the type of asset in the way that we have today with things like ISINs, etc. And so we've been working closely with the Digital Token Identifier Foundation, which is a body which has been established to issue unique identifiers relating to tokens, with those identifiers designating certain characteristics associated with the tokens, so things like the underlying ledger, the smart contracts used, and other things which can uniquely identify the token. And as part of the working group, we're discussing at the moment how we extend the model, extend the current kind of taxonomy and standards parts of the model to allow for somebody to designate or to assign a token, a digital token identifier, both as a way of, well, number one, properly identifying the token within the CDM, but I think more broadly as a way of promoting and driving the standard. And I think similar things apply for some of the ISO standards that I think have been discussed at other sessions today, but also some of the standards that have been promoted by ISDA in recent years, including some of the work that I did while I was there on trying to establish what amendments might need to be made to collateral mechanics and documentation to allow for the use of tokenized assets as collateral under a CSA. So I think CDM, really powerful tool for standards adoption in what is still a fairly nascent market. Synchronizing on-chain and off-chain records. This is something that we've looked at quite closely at Tokenovate. And the challenge here arises if you think back to the digital twin implementation that I mentioned earlier. And I mentioned this issue that you essentially have two competing not competing, they should be two complementary representations of the same thing. But the challenge you see there is not just in the kind of the legal mechanics, pinning those two things together and ensuring that the legal rights associated with the off-chain asset track through to the digital twin, to the digital object, and via transfer of the digital object on-chain. But we also want to ensure that as that digital twin moves through, whether it's the same ledger or across blockchain bridges, etc., through sort of other interoperable type solutions, that to the extent necessary, the original record, the record of ultimate legal title to that asset is kept up to date with what's happening with that token. If that token is fractionalized, for example, or spent or destroyed or transferred to somebody else, and that somebody else then seeks to claim title to that asset, the CSD needs to have that information. It needs to understand where the asset is and who is currently holding it and where they're holding it. And so we think there's an opportunity for the use of CDM more broadly across the market to better standardize the representation of assets within both traditional security systems and within tokenized settlement systems, such that we ultimately arrive at a world where assets are all described in the same way, where they have similar common or unique characteristics. Those are described in the same way. And then that makes the creation of these digital twins much more straightforward, because as a kind of as an API call, you might say, between, let's say, in this example, the CSD and the blockchain, it can use the same data formats and the same data schemas to synchronize the records as needed. So we think CDM, again, is a really powerful tool for promoting operational standardization within tokenized, the world of tokenized assets. And then more broadly, and this is sort of a slightly shameless pitch for Tokenovate. So one of the kind of the points that we're talking about in the working group is kind of fair enough to talk about how we represent assets within CDM today. So we represent them as somewhat static data objects, whether as part of an eligible collateral schedule for CSAs or as a way of kind of understanding workflows and qualifying products, etc. But looking longer term and thinking about what we're trying to do at Tokenovate, we want to turn CDM into a runtime operational model. We want it to be the kind of the underlying data model underpinning the kind of the straight-through processing and automation of the entire capital markets. And that's, you know, quite a bold objective, but I think one of the really powerful benefits of that is that once you have all of these various different operational processes and legal processes that are embedded within, is the documentation, ICMA documentation, is the documentation within automatable workflows within CDM, arguably it's only really at that point where you can start to realize the true benefits of tokenization. I think one of the mistakes or one of the failings, I think, of tokenized solutions today is that they start at the end. They create the token and then they wonder what they need to do with it. Whereas I think our view is that you need to start from the beginning. You need to sort of standardize the data, which will ultimately orchestrate the transfer and the maintenance of those assets and ensure that all of the data standards are consistent and speak to each other. And so again, this is why we think CDM is a really powerful tool, not just for tokenizing assets, but also for tokenizing settlement and all of the processes that will provide the benefits of tokenized settlement across the market. And so I'll conclude with just, again, a slightly shameless pitch for the CDM Tokenized Assets Working Group. So within FINOS, we've developed, or we've started a working group where we discuss all of these issues. Some of the key focus areas on the screen at the moment. I think we're very much in discovery mode at the moment. I think there's broad agreement conceptually on some of the things that I've spoken about, although there's always very good and robust debate. I think one of the things that we are missing slightly is real-world implementations. So it's always very difficult, something I learned at ISDA for 6 or 7 years, to develop standards before people are actually, building things and using things. It's really only through that kind of implementation and discovery process where you can really design and develop truly representative and robust standards. So for anyone in the audience who's developing tokenization solutions, who's interested in anything that I've had to say today, please do let me know. Please do join the working group. We'd love to hear from you. But thank you. I'm not sure if I have time for questions today. One question, maybe. Quick one. Yeah.
So speaking of CDM, so what's the equivalent in CDM of one token? Is it like a contract once the contract is firmed up, or is it the execution of the contract? What is it?
I'm going to give you a lawyer answer. I'm going to say it depends. So I think it depends on what you're using CDM for, would be my view. I'd be interested to hear other views. So I think if you're interested in identifying an asset as a tokenized asset, you would probably want to look at, let's say, like the asset model and think about what are the characteristics associated with an asset that you would need to include in order to characterize it as a tokenized asset. I think then if we're thinking about settling a token, like using the kind of the transfer business event or some of the settlement mechanics within CDM to sort of affect tokenized settlement, you might need to look not only at the asset that's being transferred, but also at some of the, I suppose, the underlying mechanics of things like, are you settling intraday? Are you doing an atomic settlement? So I think there's a number of different dimensions and a number of different touch points within the model. I'm not sure I've really answered your question, but happy to discuss afterwards. Yeah. Okay. Great. All right. Thanks, everyone.